Assalamualaikum and hi, welcome to our QMT342 QB theory project. First thing first, let's get to know our group members. Firstly, we have Muhammad Amrul Hakim bin Muhammad Nafi, and then we have myself, Andi Anika Putra bin Ahmad Muazzam Shah. Next, Muhammad Faris Iqmal bin Muhammad Faiz, and last but not least, Farizul Iqwan bin Zuhazli Shah. So, we have decided to do our queuing theory project at Zeus Coffee. The location of Zeus Coffee that we have chosen is number 28, Pusat Perniagaan 27600, Rau, Pahang. The operating time for Zeus Coffee is from 8 AM until 10 PM, and we did our observation at 10 AM until 11 AM. During our observation, there was only one server.
2.0 Characteristic of queuing system. We have three characters. The first one is arrival, for the second one is waiting line, and the third one is service facility. 2.1 Arrival characteristic. The pattern of arrival at the system are considered random. Arrival being described by Poisson distribution. Number of customers that arrive at the system per hour are 11 customers. We know that lambda equal to 11. For the second one, size of calling population is infinite or unlimited. The third one, behavior of the arrival exists is patient customers. 2.2 Waiting line characteristic. The length of a line is limited. Next, the queue discipline is FIFO, first in, first out. 2.3 Service facility characteristic. The first one, number of channel or number of server, is single channel system, S equal to 1. For the second one, number of phrase or number of station is single phrase system. For the third one, the pattern of service time. Service being described by exponential distribution. Total number of customers that be serviced per hour are 13 customers. We know that mu equal to 13. 2.4 Basic queuing system configuration. In our study, there is a single server to the single phrase system.
Next is characteristic of the selected queuing system. For our lambda is 11 customer per hour and our mu is 13 customer per hour. The average number of customer or units in the system is lambda per mu minus lambda equals to 11 per 13 minus 11, and we got 5.5 customers. Next, the average number of customers in the queue, we use LQ equals to lambda square per mu bracket mu minus lambda equals to 11 square per 13 bracket 13 minus 11, and we got 4.6538 customers. Next is the average time a customer spends in the system. We use W equals to 1 over mu minus lambda equals to 1 per 13 minus 11, and we got 1.5 hour equals to 13 minutes. And the average time a customer spend waiting in the queue, we use WQ equals to lambda per mu bracket mu minus lambda equals to 11 per 13 bracket 13 minus 11 equals to 0.4231 hour equals to 25.386 minutes. Next is utilization factor for the system, that is the probability that the service facility is being used. we use rho equals to lambda per mu equals to 11 per 13 equals to 0.8462, and the percent idle time, that is the probability that no customer in the system, we use P0 equals to 1 minus lambda per mu equals to 1 minus 11 per 13, then we got 0.1538.
Okay, hello. My name is Muhammad Faris Ikmal bin Muhammad Faiz. So, right now I want to talk about conclusion. So, don't waste your time. Let's go to the following page. Let's go. Okay, so now I want to talk about conclusion. First and foremost, we can learn how the assumption of commonly used model are handled from this project. Second, while working on this project at Zeus Coffee, we learn how to explain the fundamental setups of the queuing system. Besides, when we visit Zeus Coffee to work on our project there, we can observe that customers are happy since they receive outstanding service. In addition, Zeus Coffee in Raub has an average of 11 people each hour who came to purchase food and beverage. Last but not least, the number of servers provided is reasonable because there is a maximum wait of 12 minutes for each customer. Okay, so right now let's go to the next page. Okay, so right now we are at second last page of our slide. If you can see, this is a photo of us at Zeus Coffee. We visited Zeus Coffee on January 18, 2023 around 10 AM. Okay, so that's all. Let's go to the last page. Okay, so that's all from us. Thank you.